Dear all, I'm Liliana CIMPOIES, Associate Professor at the Academy of Economic Studies of Moldova, and together with my colleague, would like to present you our paper titled Climate Resilience and Yield Vulnerability of Key Crops in Moldova, a case study of wheat, maize, and sunflower. The aim of this research was to assess the impact of climate change on the crop production sector in Moldova, focusing on three main crops as wheat, maize, and sunflower during 2007 to 2024. The aim of this analysis was to identify the degree of resilience and vulnerability of these crops according to variations in the average annual temperature and rainfall regime. The analysis included the calculation of descriptive statistics, also Pearson correlation coefficient were applied to identify relationships between crop yields and climatic factors. Multiple regression models were developed for each crop to estimate the combined influence of temperature, precipitation, and cultivated area on production volume. And additionally, polynomial regression functions were generated to analyze long-term yield trends. Referring to the impact of climate change on the agricultural sector, we could mention that between 2010 and 2024, the climate in Moldova was warmed steadily above the norm, with record highs during 2020 and 2024, while precipitations presented different fluctuations generated by severe drought years, underscoring the intensifying extremes of climate change. Wheat production in Moldova is highly dependent on rainfall during key growth stages, with 2022 standing out as the most unfavorable year due to severe precipitation deficits, while in some years as 2016, 2017, and partially 2024 benefited from balanced rainfall, confirming the crop's vulnerability to climate changes. Regarding sunflower, we could say that it's a crop that adapts quite well to weather conditions, but yield stability is influenced a lot by rainfall. During 2022, it was marked by severe winter moisture deficits, and in 2018 offering favorable conditions for soil water replenishment before sowing. Regarding the third crop analyzed, maize, despite being relatively resilient crop, it shows strong dependence on rainfall, with drought years like 2015 and 2022 severely reducing yields, while favorable conditions in 2017 and 2021 supported strong growth, highlighting its high sensitivity to precipitation variability across different critical growth stages. Regarding polynomial analysis, we could mention that sunflower is the most stable crop with a strong correlation between years and yield of 0.73, confirming a good drought resilience. Maize was severely affected in drought years, as for instance in 2022, with a statistical model showing a high variability in output of 0.37. And regarding wheat, being particularly sensitive to soil moisture in autumn and spring, showed different fluctuations with a moderately predicted trend having a regression coefficient of 0.41. Out of the three crops analyzed in this research, we could mention that maize exhibits the highest level of instability. The high coefficient of variations for both production and yield indicate increased susceptibility to environmental factors, particularly drought during critical growth stages. Even though its average production and yield are even better than those of for wheat, for example. With a coefficient of variation of 36.8, the areas likewise exhibit notable fluctuations. Sunflower exhibits a moderate level of stability, and sunflower has a comparatively greater tolerance to local conditions with an average yield of 17.1 quintals per hectare and an average production of 4.76 million quintals on roughly 272,000 hectares. The production coefficient of variation and yield coefficient of variation indicate that climate variability has a moderate impact. Regression results also show that wheat and maize yields are strongly shaped by precipitation, with head stress reducing outputs, while sunflower proves more resilient but still vulnerable under combined head and drought. In all cases, expanding cultivated area helps production but cannot offset adverse climate effects. In conclusion, we could mention that agricultural performance is strongly influenced by climate, especially precipitation level. Maize from the analyzed crops is the most vulnerable to drought, manifesting high yield fluctuations. Wheat is moderately stable but highly sensitive to rainfall, especially in fall and spring, while sunflower is the most resilient crop with quite stable yields under stress. Underwater stress. Regression analysis also confirms that precipitation is a key factor which affects yield, while temperature effects can vary by crop. And the most variable to eat is maize after sunflower and after wheat. As possibilities to adapt to climate change, is recommended using drought-resistant varieties, irrigation expansion, soil moisture conservation, and climate-aligned farming calendars. And also ensuring food security requires a strategic and adaptive agricultural approach. Thank you very much for your attention.